If you recall, a quadratic relation can take on three different forms: standard form, factored form, and vertex form. In all three formats, the a value told you if your parabola was opening up or down. In vertex form, we know that the letters h and k represent the coordinates of the vertex. But what else can h and k tell us about a parabola? In this video and lesson, we will be focusing on transformations of quadratic relations, meaning how to take a simple basic parabola and use the values of a, h, and k to change the shape of the parabola and move the parabola around the Cartesian plane in both the horizontal and vertical directions. Graphing relations by transformations can be very useful in sketching complex relations. We typically start with what we call a base function or a parent function, and then we transform it based on values that are in the equation. We will use the graph of y equals x squared as the base of all our transformations of parabolas, and we will only be working with equations that are in vertex form. Before we begin our discussion about transformations, we need to determine the points of our base function, and we are starting with the function y equals x squared. So we're going to start by creating a table of values for our parent equation, and I've gone ahead and filled in the x column of my table of values with some pre-chosen values. So I've chosen to focus on a range of values from -3 to +3. You can choose any values you want, really, but these are typically the range of numbers that we pick for highlighting or showcasing the points on our parent function, y equals x squared. So I'm going to go ahead and calculate the corresponding y values by plugging in each x value into my equation. So -3 squared would be a +9, -2 squared would be a +4, -1 squared is +1, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. So we can clearly see that this does represent a true parabola because we have a set of values in our y column, and they are steadily decreasing up until the value of 0, and then they begin increasing again, and we are seeing repetition of the same values. So 0, 0 seems to be our minimum or lowest point on our parabola. We're now going to go ahead and take these particular coordinate points, and we're going to go ahead and plot them on our grid that we have here on the side. So once you go ahead and plot your points, you do get a parabola that looks like so. So you have a parabola that is opening upwards, and it's got a minimum point or a vertex located at the origin, so the point 0, 0. So this table of values and this particular parabola that we have graphed represent our most simple basic parabola. So the equation y equals x squared is going to be referred to as our parent function from this point onwards. So in our parent function, we are dealing with a minimum, since our parabola opens up and our vertex is located at the bottom of our parabola, or the lowest point of our parabola. The vertex is located at the point 0, 0, and our a value is 1. There is no other value in front of the equation. It's just simply y equals x squared. And our a value also happens to be a +1. And because it is a positive, that is what gives us a parabola that opens upwards. So in the rest of this lesson, we're going to be investigating different types of parabolas, and we're going to focus on the three specific values of a, h, and k, and what those specific values or numbers do to the shape and the location of our basic parent function. And in the following investigations, we will always start with our parent function, y equals x squared, and then we will build on top of that. To start off with, we are going to take a look at horizontal and vertical translations. So this means taking our base or parent function or our base parabola of y equals x squared and shifting it either to the left or to the right, so that would be a horizontal translation, or taking our base parabola and shifting it upwards or downwards. That would be a vertical translation. Now, to figure out if we are going to go left or right or up or down, we are going to pay specific attention to the values of h and k in our quadratic equation. So this is why we are only looking at equations in vertex form, because that is where we find the letters h and k. So let's start with looking at vertical translations. Now, like we mentioned before, we are always going to start with our parent function of y equals x squared, and that is the graph that you see in front of you on the screen. So I went ahead and I just plotted the same points from our table of values that we just created, and that creates our parent function of y equals x squared. Now, what happens if I were to add on to the equation y equals x squared? So let's say, for instance, I turned it into y equals x squared plus 3. So if I were to create a table of values for this equation and plot it on the same grid, so right on top of my parent function, this is what it would look like. So the graph that is now shown in blue represents the equation y equals x squared plus 3. So I'm just going to go ahead and just color that or highlight that for you so you know that the blue represents this equation and the red is always going to represent our parent equation. So what's the big difference between these two? What has happened? So the red represents our parent equation and the blue graph has shifted upwards. And we can actually tell how many units it's shifted upwards by looking at our vertex. Remember, the vertex for our parent equation was located at the origin, the point 0, 0. But the vertex on our brand new equation is located at the point 0, 3. So it has moved up 1, 2, 3 units. And that makes sense because all we did to the actual equation was add 3. Now, what happens if I changed my equation, but this time I changed it to y equals x squared minus 4? So I'm going to do the same thing. I'm going to plot this third equation onto the same grid, and you're going to be able to compare and contrast between all three. So the graph for y equals x squared minus 4 is now plotted, and it is in green. So what's the difference here? If we were to compare this graph to the original graph in red, we can see that the green line, or the green parabola, has moved downwards. And how many units has it moved downwards? Well, again, if we were to compare the vertex, so the vertex on the parent function was 0, 0. The vertex of our new graph has shifted downwards to 0 and negative 4. And remember, the only thing that we changed in our equation was we added in this value of negative 4. So what it seems to be telling me is that anytime I add an outside value, it's either going to shift my parabola upwards if it's a positive number, like we saw in positive 3 here, our graph shifted upwards by 3 units, or if it's a negative value, it's going to shift our graph downwards. So when we had x squared minus 4, that pushed my parabola downwards by 4 units. So that outside number that we're talking about, so the number that was showing up beside x squared, that's actually the k value in our vertex form equation. And what we found or discovered was that whenever our k value was greater than 0, meaning whenever we had a positive value, this shifted our parabola upwards by however many units was in the equation. So if we saw a plus 3, then the parabola moved up 3 units. If you had a plus 5 instead, that would have moved your parabola up by 5 units. On the flip side, when our k value was less than 0, meaning when we had a negative number, this shifted our parabola downwards. So whatever number showed up in the equation, it would shift your parabola down by that many units. So we looked at x squared minus 4, and so our parabola moved down by 4 units. So now let's go ahead and take a look at horizontal translations. So again, we're going to start by using our parent parabola or parent equation, y equals x squared. And again, I've gone ahead and graphed that here in red for you. So if I take my original parent equation. And now instead, I'm going to add 3 inside my brackets, and I'm going to square it. Remember, this is what a vertex form equation tends to look like. It has an x term and a value enclosed inside a set of brackets, and then the whole entire bracket is squared. So instead of adding the number on the outside, like we just looked at with the vertical translations, what if I added the number inside the bracket instead? And it turned into x plus 3 squared. So I'm going to go ahead and graph that on the same grid, and you're going to be able to see what happens. So here's what the graph would look like. So in this kind of purpley dark blue color, that is the graph for y equals x plus 3 squared. So what do we notice in terms of the difference between the original parent equation and this brand new equation? Well, it seems like my brand new graph has shifted over to the left. Remember, our parabola started or was centered around the vertex 0, 0. But now this brand new parabola has a vertex that is located at the point -3 and 0. So it seems like it has shifted to the left. Now, to most students, that seems kind of counterintuitive because when they look at the equation, they see a value of +3 and they think to themselves, well, a positive value in math usually implies that we're shifting to the right horizontally. But unfortunately, with vertex form, the h value tends to be the opposite. So although you are seeing a +3 inside the bracket, that is signifying that it's actually shifting the parabola to the left. So now, what happens if I make my equation y equals x minus 4 squared? So I'm going to go ahead and plot this third equation onto the same grid. Okay, so as you might have predicted, this brand new or third parabola actually shifted over to the right. And we can tell how many units it shifted over by again taking a look at the vertex. So the vertex of our parent equation is located at 0, 0, but this brand new parabola has shifted over 4 units to the right. So again, although our equation had a -4 or a -4, and you might think, well, a negative value might imply an actual shift to the left because negative and left usually match up and go together. It's actually the opposite. So when you're seeing a negative value inside your bracket in your equation in vertex form, it's actually pushing your parabola over to the right. So let's summarize those findings because the horizontal translations can sometimes be a little tricky. So when you have an h value, so that's the number inside the bracket, when that value is greater than 0, meaning you have a positive number inside your bracket, you are going to shift your parabola to the left. So that means you're going to the left side of your Cartesian plane, and on the flip side, when you have an h value inside your bracket that is less than 0, meaning it is negative, so you have a negative number inside the bracket, that means you're going to shift your parabola to the right. So we're going to take a look at both of those translations, vertical and horizontal, and we're going to take a look at different equations of parabolas in vertex form, and we are going to list the transformations that have been applied to our original graph. So remember, our original function was y equals x squared, and now I've made some alterations to it and created 3 brand new equations. So we're going to take a look at each one, and we're going to list out the way that the parabola has been changed. So first of all, if you are confused as to why you're seeing this notation with an f and an x, this just represents the term function in mathematics. It's the same thing as saying y equals x plus 3 squared minus 1. So don't get too hung up over it now, but it just means the term function, or it's just expressing that this parabola is a mathematical function. So when you are looking at an equation and you need to list out the transformations, you always want to look at your equation and read it from left to right. So that means you want to start right at the very front of the equation and scan it towards the right. So the first thing that I come across is this positive 3. And I know that the number that is inside my bracket represents a horizontal translation, and it also represents my h value. So remember, with our h values, this is where we kind of had to go the opposite way. So if you have a positive h value in your bracket, that signifies a horizontal shift to the left. If you have a negative value or a negative h value inside your bracket, that signifies a horizontal shift to the right. So in our particular equation, we have an h value of positive 3, which actually tells me that my parabola is going to shift to the left. Now, how many units is it going to shift over to the left? Well, it's going to shift over 3 units to the left. So we're going to write that out. So the proper way to write this out would be to say a horizontal shift to the left by 3 units. Now, instead of the word shift, you might also see the term translation. Those words could be used interchangeably. Your choice, either one would be correct. But you do need to imply that it is a horizontal shift or horizontal translation. You need to give the direction, so it's either going to be left or right, and you need to state how many units it is shifting over. And so for us, it was shifting to the left by 3 units. The next thing that I see as I scan my equation from left to right is this -1. Now, the -1 is located on the outside or at the end of the equation, and I know that this symbolizes my k value. Now, the k value, remember, tells you whether or not you have a vertical translation, and it's also going to tell you if that vertical translation is moving upwards or downwards. Now with the k value, it's nice and straightforward. If you have a positive k value, you're going to move upwards. If you have a negative k value, you're going to move downwards. Now, since we have a k value of -1, that tells me that my parabola also has to be shifted 1 unit downwards. So if we were to write it out, this is what we would state. We would have a vertical shift down by 1 unit. Again, if you don't want to use the word shift, you might also see the word translated. So you could say vertically translated down or downwards by 1 unit. Again, you must include the word vertical because vertical is what signifies whether it's going up or down. You have to use the word up or down because you need to state whether it's going up or down. And you also need to say or state how many units it is being shifted by. So let's take a look at our next one. So this equation is x minus 1 squared. So again, we're going to start at the very front of our equation and scan our way towards the right. So the first thing I notice is that I have a value of -1 inside my bracket. So I know that this is an h value, which tells me that my parabola is either going to shift to the left or to the right. Now again, remember our sign notation. Because we have a -1 inside the bracket, that tells me that my parabola is actually going to shift towards the right. So if I'm going to write out that transformation, I'm going to say a horizontal translation to the right by 1 unit. Since my h value is 1, it's got to be 1 unit. And again, you can use the word translation, you can use the word shift. You just want to get comfortable with using either one and recognizing both of those words. Now, the next thing I'm going to do is scan and see what my k value is. Now, it doesn't actually seem like there is a k value. But the k value, if you don't see one, it's actually 0. And the reason why they leave it out is because there really is no point to saying x minus 1 squared plus 0. That's like saying plus nothing. Now, because your k value is 0, that means you're actually not moving anywhere. You're just staying in the same vertical spot. So you're not shifting upwards, but you're not shifting downwards. So this particular parabola only has a horizontal translation to the right by 1 unit and nothing else. In our last equation, we have y equals x squared plus 5. So this time, we don't visibly see that set of brackets that we normally see in a vertex form equation. So what does that mean when you don't have that bracket appearing in your equation? It's just x squared plus 5. Well, when you don't have that set of brackets, that means that there is no horizontal translation. So that means your parabola is not being shifted to the left or to the right. It's going to stay where it is in its horizontal position. However, this parabola does have a k value, and so our k value is a positive 5. So when you have a k value that is a positive value, that implies that it is being shifted upwards. So we are going to write out our transformation by saying that we have a vertical translation upwards by 5 units. So we would simply be taking our original parent equation, y equals x squared, and we would be translating it or shifting it upwards by 5 units. In example number 2, we are asked to write a quadratic function or equation, same thing, with the associated attributes. So this time we are given a bunch of different transformations, and based on that information, we need to come up with the equation. So remember, our equation is always going to look like a vertex form equation, and all we have to do is input the values of h and k. So in our first example, we have a vertical translation 4.5 units up and a horizontal translation 0.5 units right. So it is perfectly normal to see decimal values. It's also perfectly normal to see fraction values. You can have a whole slew of different types of numbers. You can still use those numbers in your equation. So let's start with the horizontal translation. That's going to come first, since our horizontal translation represents our h value, and the h value is the number that goes inside the brackets. So I'm going to go ahead and start writing out my equation. I'm going to say y equals, I'm going to open the bracket, I'm going to put in an x. Now, the question is telling me that we're horizontally translating or horizontally shifting our parabola 0.5 units to the right. Now, remember, if we are shifting to the right, that means we need to have a negative value inside our bracket. So we're going to put in a negative sign, and then we're going to put in the number of units, which is 0.5. We're going to close the bracket, we're going to square it, and then we're going to check and see if we need to put in a k value. A k value, remember, represents a vertical translation or vertical shift. Now in the question, we are told that there is a vertical translation. We are translating 4.5 units up. Now to go upwards means that you need to see a positive number on the outside of your equation, so we are going to fill in a positive 4.5. In question B, we need to come up with an equation for a vertical translation 8 units down. So there are no horizontal translations given to us, so that means our equation is not going to have the same set of brackets that we saw in the first equation in question A. So because of this, we can just go ahead and write y equals x squared, but we do have a k value that corresponds to our vertical translation. We happen to be shifting this parabola 8 units down. So down implies that we need to put in a minus sign, and the value or the number of units would be 8. So the equation would be y equals x squared minus 8. In question C, this time we are only looking at a parabola that has a horizontal translation 3/4 or 3/4 units left. So this time there is only a horizontal translation, no vertical translation. So we have a horizontal translation, which means we need to have a bracket. It's going to get squared. Inside our bracket, we have the letter x. Now, in terms of whether or not it's going to be positive or negative, let's check the direction. So we are shifting this parabola to the left. So remember, if we want to shift it to the left, we need to put in a positive sign. And then we're going to input the number of units. We are shifting it 3/4 to the left. So we can also put in 3/4. If you don't like the 3/4, you could change it to a decimal. Remember, 3/4 is the same thing as saying 0.75. So if you'd like to use that value, it's the same thing, they're equivalent. So you could use a decimal instead. We don't have a k value for this particular equation because there was no vertical translation given to us. So that means we are not shifting this particular parabola up or down, so there will be no k value. And in the last question, we are asked to come up with an equation for a parabola that has a vertex of -4 and 6. Now, they try to trick you here and be clever by not giving you any kind of information about transformations. And, you might get confused and think, well, isn't that what this lesson is about? But remember, this is kind of a trick. What letters do we know represent our vertex? Your vertex is always represented by the letters H and K. So you already know what numbers you need to input into your equation template. So you know your H value needs to go inside the bracket, and you know your K value needs to go on the outside or the end of your equation. So if we were to go ahead and build our equation, we would start off by saying y equals, we're going to open the bracket, we have an x, and our H value is -4. So remember, if we are seeing it written as -4, we need to put the opposite into our actual equation. So the opposite of a -4 would be a +4. We're going to close the bracket, we're going to square it, and then we're going to input our k value. Remember, you can write your k value exactly as you see it. So it was given to us as +6, so we are going to write it as +6. So our equation for this parabola would be y equals x + 4 squared + 6. One of the best ways to highlight a transformation is to actually sketch or graph the equation. So we're going to go through two different examples where I'm going to show you how to sketch a transformed parabola. Now, in order to do this, you always need to start by graphing your parent equation or your base parabola. So remember, that was our parabola, y equals x squared. Now, over time, you will eventually commit those points for your parent parabola to memory. You won't have to always refer to the table of values that we created at the very beginning of this lesson. You might not even have to recalculate them. You'll just always know what those points are. So I'm going to go ahead and quickly graph my parent parabola onto the grid for our first example. And then we're going to take a look at the newly transformed equation that we were given. And I will show you a very quick way to generate the brand new points for this parabola without having to plug in all the numbers and solve for all the y values and create a whole brand new table of values. There is a much easier and faster way to do it using what we call a mapping rule. So I've gone ahead and graphed my parent function or parent parabola on my Cartesian grid, and I used the same numbers that we used in our previous table. So in case you've forgotten those, here is the table of values. Now, our previous table started at -3 and ended at +3. I just shortened it down to make it a little bit quicker. I would say at the very minimum, you should be looking at a table that starts with an x at -2 and ends with an x of +2. If you want to make it longer, you totally can, but I wouldn't suggest going any smaller than this. So you should have a total of 1, 2, 3, 4, 5 points. So this was the original table of values for that parent function, y equals x squared. Now the question is asking us to take that parent equation and turn it into this equation, y equals x minus 4 squared minus 3. So remember that the h value inside the bracket and the k value outside at the end of the equation represent horizontal and vertical shifts, or horizontal or vertical translations. So we can take those values and apply the transformations. And the way that we're going to do that is by focusing on the table of values. So what we're going to do is we are going to generate a brand new set of coordinate points for our transformed equation, and then we're going to plot those points on the same grid and create the graph for the brand new equation. So let's start with our x values. So we're not just going to be simply using the original x values. The x values have been changed. So if we go back to our equation here, our horizontal translation is represented by a value of -4. Now remember, when you see a negative inside the bracket, that implies that your parabola is being shifted to the right. So that means we're going to go back down to our table here, and it's telling me that I'm going to take my original x values, and to them I'm going to do the opposite. So instead of minusing 4, as was written in the equation, we're going to do the opposite, which is to add 4. Now for my y values, to figure out how I'm going to shift those around, I need to go back to my original equation and look at my k value. My k value is a -3. Now remember, we don't play around with the k value. Whatever we see it written down as, that's how we use it. So for my y values in my table, I'm going to take all of my original y values, and to them I'm going to -3. So let's start filling in our x column. So we need to take our x values from our original table of values and add 4 to each one of them. So I'm going to start from the beginning. My first x value in my original table was -2. To that, I'm going to add 4. I'm going to repeat all the way down my table. So I've got -1 plus 4, 0 plus 4, 1 plus 4, and 2 plus 4. So -2 plus 4 is 2, -1 plus 4 is 3, 0 plus 4 is 4, 1 plus 4 is 5, and 2 plus 4 is 6. So these are my brand new x values for my transformed parabola. I'm going to do the same thing for my y values. So I'm going to take all of my original y values, and each of these needs to be subtracted by 3. So I'm going to start with my first value, which was a 4. I'm going to -3, and then I have 1 minus 3, 0 minus 3, again 1 minus 3, and again 4 minus 3. So that's going to leave me with values of 1, -2, -3, -2, and 1. So these are my brand new y values. So together, these x and y values represent the brand new coordinate points that you are going to go ahead and plot onto your grid. So if I were to take these brand new points, so for example, my first data point is going to be located at 2 and 1. My next point will be located at 3 and -2, and then 4 and -3, and so on. That would give me a parabola that looks like this. So remember, you have your original parabola sketched in red, and then you have your brand new transformed parabola sketched in blue. So you can see very clearly that there has been a shift, and in particular that shift was 4 units to the right and 3 units down. If you'd like to give it a try, here's a brand new equation. Y equals x plus 5 squared plus 1. So you can go ahead, pause the video, see if you can come up with the brand new data points that would match this equation, and plot it along with the parent equation on the same grid. If you feel like you've gotten a solution, you can come back, hit play on the video, and check your answer. So in this equation, we have both a horizontal translation and a vertical translation. Our horizontal translation is represented by this +5, and our vertical translation is represented by this +1. Remember that your horizontal translation is going to impact all of the x values from your original table of values, and your vertical translation is going to impact all of your y values. So remember that if you are seeing a +5, we're really going to interpret it as a -5. So that means all of my x values from my original parent table of values, they need to be subtracted by 5. All of my y values need to have a 1 added to them, since we don't need to change this value. So if our k value shows up as +1, we're going to keep it as a +1. So if you go ahead and fill in your table, you should have something that looks like this. So I've taken all of the x values from my original parent table of values, and each one got subtracted by 5. And I took all of the original y values from my table, and each one had 1 added to it. Once you calculate all of your brand new x and y values, you are ready to go ahead and plot them onto your grid. So remember, you have a brand new set of x and y values that will represent brand new coordinate points. So as before, you should always have two parabolas on the same grid. So the red one, as always, represents our base or parent parabola, y equals x squared. And this one in green represents our brand new transformed parabola. Now, in terms of comparing the two, the one in green has been shifted over 5 units to the left, because remember, we subtracted 5 from all of our x values, and it also has been shifted 1 unit up. Remember, our k value was a +1, which implies that all of our data points need to be shifted upwards by 1 unit. So we've looked at h and k and seen how they represent horizontal translations and vertical translations. The last piece of the puzzle is to look at the a value. Now, the a value is going to correspond to a vertical stretch or a vertical compression. So to stretch or compress a parabola vertically means you're going to take your parent parabola, remember that original basic parabola. If you're going to stretch it, that means imagine holding your parabola and just stretching it vertically and making it more narrow and skinnier. If you were to compress your parabola, that means you would be pushing down on your parabola, making it more shorter, fatter, stouter, wider looking. And all of that information comes from the a value. Now remember, the a value is the value right at the very front of your parabola. Now, the a value is really special because there's a lot of information that it can tell us. So it's either going to tell us if we are going to stretch, compress, or even reflect our parabola. So when our a value is greater than 0, meaning when your a value is positive, there is no reflection. And we know that when our a value is positive, our parabola simply just opens in an upwards direction. So it looks like a regular U-shaped parabola. However, when you have an a value that is less than 0, meaning when you have a negative a value, your function or your parabola, we say that it is reflected in the x-axis. So that's a fancy way of saying you're going to take your parabola and you're going to flip it over. So now this is a parabola that opens downwards. So if you have a negative a value, you are going to reflect your parabola or just basically turn it upside down. Now, in terms of how to tell if your parabola is going to be stretched or compressed, you are going to look at the actual number of your a value. So if your a value is greater than 1, so you have a number bigger than 1, we're going to say that our parabola is vertically stretched by a factor of a. So for example, if your a value is 10, you're going to say your parabola is vertically stretched by a factor of 10. Now, if your a value falls in between 0 and 1, so this typically means you have an a value that is a decimal or a fraction, a very small number. So something like 0.25, 0.01, 0.5, 3 over 4. That tells you that your parabola is being vertically compressed. So for example, if your a value was 0.25, you would say your parabola is being vertically compressed by a factor of 0.25. So let's take a look at all three of our transformations now combined together and applied to our parent equation of y equals x squared. So again, as always, you're going to scan your equation from left to right and identify all of the different transformations that are attached to the equation. So you're going to start at the very front of the equation and check and see what your a value is. So first of all, is your a value positive or negative? Well, we happen to have a positive 3. So because my a value is positive, that tells me that my parabola has not been reflected. So this is just a regular parabola that opens upwards. The next thing I want to check is the actual value of a. So my a value is 3. Now 3 is a number that is greater than 1, so that tells me that this parabola has been vertically stretched. So that's our first transformation that we need to list out. So we are going to say vertical stretch by a factor of 3. As I continue scanning, the next thing I notice is my h value. I have an h value, which means that there is a horizontal shift or a horizontal translation. Remember, we always need to interpret this as the opposite. So if we are seeing a -1, that means our parabola is going to move to the right. So if we were to list this, we would say there is a horizontal translation to the right by 1 unit. And there doesn't happen to be any k value on the end or the outside of my equation, so that tells me that there is no vertical translation. This parabola is not moving up or down. Here's our second equation. So again, we want to start right at the very front of the equation, and the first thing that I happen to see is a negative sign. So seeing a negative sign means that your parabola opens down, but in proper math terminology, we need to say that our parabola has been reflected in the x-axis. So that's the very first thing that we're going to list. The next thing we want to check is the actual a value. So this time we have an a value of 0.4. Remember, if you have an a value that falls between 0 and 1, that means your parabola is being vertically compressed. So that would be our next transformation. So we're going to say there is a vertical compression by a factor of 0.4. The next thing I see is my h value. So I have an h value of -2 or -2. This tells me that my parabola is being horizontally translated or horizontally shifted 2 units to the right. So I've added that to my list. And finally, we're going to take a look at our k value. Our k value is -5, and when you have a negative k value, that implies that your parabola is being shifted downwards or vertically translated downwards. So we're going to add that as our final transformation. So we're going to say a vertical translation 5 units down, or you could say 5 units downwards as well. See if you can try this one on your own. So you've got an equation of y equals negative 2 x plus 1 squared minus 9. So you're going to list out all of the possible transformations that are being applied to this parabola. So this parabola has a full set of transformations. So if we start at the very front of the equation, the first thing that we see is a negative sign. That tells us that our parabola is opening down, but the proper terminology is to say that this parabola is being reflected in the x-axis. The next thing I see is my a value, and I have an a value of 2. Since 2 is a number that is greater than 1, that tells me that my parabola is being vertically stretched. So I've listed that as a vertical stretch by a factor of 2. The next value is our h value. Our h value shows up in our equation as a positive 1, but that really means that our parabola is being shifted to the left. So in particular, we would state this as a horizontal translation, 1 unit to the left. And finally, we have a k value of negative 9, which implies that the parabola is being shifted downwards. So we would state that as a vertical translation, 9 units down or 9 units downwards. All right, let's try going the opposite way. So this time we are given a list of transformations and we need to turn that into an equation. And we have a mix or a combination of vertical stretches and compressions, horizontal translations, and vertical translations. So in our first question, we have a vertical stretch by a factor of 2 and a horizontal shift to the right by 4 units. So a vertical stretch represents our a value. So that means right at the very front of my equation, I need to have a value of 2. So I'm going to go ahead and put that in. So I've got y equals 2. And then we have a horizontal shift to the right by a factor of 4. So that means this is corresponding to my h value. So I'm going to go ahead and open a bracket. I'm going to put in an x. If we are shifting to the right, that means we need to see a minus sign in our equation. I'm going to put in the 4, I'm going to close the bracket, I'm going to square it, and I don't have any information given to me for a vertical translation or a vertical shift, so that means I'm not going to include a k value at the end of my equation. In question B, we've got a reflection in the x-axis, a vertical compression by a factor of 0.5, and a vertical shift down by 4. So again, we're going to start our equation with y equals. The first thing we're given is a reflection in the x-axis. That simply implies that you need to put a negative. We've got a vertical compression by a factor of 0.5. That corresponds to my a value, so the number right at the very beginning of my equation. So I'm going to put in a 0.5. Now, we're not given any information about a horizontal shift, so that means that this particular equation is not going to have the usual set of brackets that we are used to seeing. So without that set of brackets, you're simply just going to have an x squared, similar to what you would see in your parent parabola or your parent equation. We do, however, have a vertical shift. We are shifting this parabola downwards by a factor of 4 units. So if we're shifting downwards, that is a minus sign, and we're going to put in the number 4. So this parabola would have an equation of y equals negative 0.5x squared minus 4. And finally, question C, we have a parabola that has a reflection in the x-axis. This is actually a typo, so I'm just going to correct it really quickly. This should be a reflection in the x-axis, and it has a vertex located at negative 2 and 1. So we're going to go ahead and start with y equals. A reflection in the x-axis means that we should see a negative sign. Now, they didn't tell me anything about the parabola being stretched or compressed. Now, if you are not given that information, that means that your parabola is not being stretched and it's not being compressed. So your a value is simply just going to be a 1. Now, in math, we don't need to write a value of 1, and typically when your a value is 1, you never see it put into the equation. so we're just going to leave it as is. We do have a vertex, though, given to us, -2 and 1. And remember that your vertex represents your h and your k values. So in the equation that I'm building, I'm going to go ahead and open up a bracket. I'm going to put a squared. I'm going to put in an x. And now I just need to fill in my h and my k. So my h is given to me as -2. So I need to write the opposite into my equation. So I'm going to put in a +2. And my k value, I can keep it exactly the way that it is. So my k value is a +1, so I'm going to write a +1. So my final equation would be y equals -x plus 2 squared plus 1. All right, we've reached the end. We're going to take all three transformations and we're going to see how to practice graphing them. So I've got two different equations. We're going to start with the first one, and I'm going to show you how to graph your transformed parabola. Again, we're going to be following that same type of mapping rule where we're taking the table of values from our original parent equation and we are applying the transformations to our x and y values to create a brand new table of values. Our first equation is y equals 2 multiplied by x minus 4 squared minus 3. So if we were to first just quickly highlight what the transformations are, we have an a value of 2, which means we have a vertical stretch by a factor of 2. We have an h value of -4, which really means that we are going to be applying this to our table of values as a +4. And we have a k value of -3. So I'm going to go ahead and show you now how to set up your table of values. We've already looked at how to apply the h and k to our x and y values, but now we've got our a value, and I'm going to show you how your a value gets incorporated into the mix. So I've gone ahead and recopied or rewritten my original table of values for my original parabola, y equals x squared. And now I'm ready to go ahead and create my brand new table. All I have to do is just figure out how is my x values going to be manipulated and how are my y values going to be manipulated. So remember, our h value was a -4 or a -4. So really that's going to mean that all of my x values actually need to get added by 4. Remember, it's always the opposite with your h value. Now with our y values, we look at what the k value was in our equation, and we had a k value of -3. So that means that all of my y values are simply going to get subtracted by 3. So now the last value that we didn't touch upon was the a value, and we had an a value of 2. Now an a value of 2 corresponds to a vertical stretch, but then how does it correspond to our table of values? You're actually going to multiply all of your y values by 2. So first you're going to multiply your y values by 2, and then you are going to subtract them by 3. So multiplying your y values by 2 is going to allow you to see how your parabola is going to get stretched out once we graph it onto our grid. Because remember that an a value of 2 corresponds to a vertical stretch. So if you were to go ahead and calculate your brand new table of values, these are the values that you would get. Be careful, again, when you are calculating your brand new y values, remember that you need to multiply first. So it would have been 2 multiplied by 4, which is 8, and then 8 minus 3 gives you 5. So just be careful that you're following bad math at all times. So with my brand new set of x and y coordinate points, I'm going to go ahead and graph both sets of points on the same grid. So here is a very rough sketch of both of my parabolas. Again, I have my parent equation, y equals x squared, in red, and I have my new equation in blue. So you can see that there is a little bit of a visible difference between the two, where the blue parabola, which represents our transform parabola, is stretched. So there is a little bit more of a narrower shape, and you can see that between some of the data points there is a longer bit of stretch of a line that we had to draw in between the 2 points. So that factor of 2 that we had to stretch our parabola by really does make a difference. With our second equation, y equals 0.5 x plus 5 squared plus 1, there actually is a little bit of a typo here. There should have been a negative in front of this 0.5, so I'm just going to go ahead and just insert it right in there. So if you'd like to go ahead, pause the video, try it on your own, see if you can generate your own table of values and create your new parabola. So before we take a look at what the table of values should look like, let's just quickly go through what the actual transformations are for this parabola. So if we start at the very front of the equation, we have a negative sign. The negative sign implies that this parabola has been flipped and it is now opening downwards. And again, the proper terminology that you would use to describe this transformation is that it has been reflected in the x-axis. The next thing I notice is that I actually have an a value, and my a value is 0.5. This means that my parabola is going to be vertically compressed. So it's going to look a little bit more shorter and kind of fatter and wider than my regular base parent parabola. I have a horizontal translation of positive 5. So remember, we're going to read this as the opposite when we create our table of values. And I have a k value of positive 1, so there is a vertical translation as well. So when we're creating our mapping rule, so how are we going to be changing our x and our y values? So for our x, we had an h value of positive 5. Remember, we're going to read that or interpret that as the opposite. So we're actually going to record it as a minus 5. So all of my x values are going to get subtracted by 5. Now with my y values, let's start with the k value. So the k value was a positive 1, so we're going to add a 1 to all of our y values. In terms of the a value, our a value was 0.5, so we're going to go ahead and put that in front of the y. So that means that all of my y values need to get multiplied by 0.5 first. But then also don't forget that there was a negative sign in front of the equation as well. So we also need to incorporate that right at the front. So you are actually going to take all of your y values, your original y values, you're first going to multiply them by negative 0.5, and then you are going to add a 1. So here are your brand new values for your brand new transformed parabola. And you can clearly see that this parabola really has been compressed down. If you take a look at what you get for your y values, you can see there isn't a real big range of numbers. The numbers are so very close together. We even have some decimal numbers. So you can tell that this actually has been compressed, whereas if you compared it to your original set of y values, there is a little bit more of a gap between each of the y values. And here's what your parabola would look like. So you can see, compared to the original parent equation, y equals x squared, your transformed parabola is much more shorter and kind of fatter and wider. And that is because of the vertical compression by a factor of 0.5. Also, your parabola has flipped over and it is now opening downwards, and that was because of the negative that was in front of our equation. Remember, that caused our parabola to be reflected or flipped over. So to summarize, we looked at transformations of quadratics in vertex form. And if we are focusing on our a value represents a transformation in the vertical dimension. If your a value is a number greater than 1, you will have a vertical stretch. If your a value is a number that falls between 0 and 1, that represents a vertical compression. And if you have a negative sign at the very front of your equation, that represents a parabola that has gone through a vertical reflection in the x-axis. This means your parabola has been flipped over and it is now opening downwards. Your h value represents a horizontal translation or a horizontal shift. It can either shift to the right or to the left. So if your equation shows up as a minus h value, you're going to report that as a horizontal translation to the right. If your equation has a positive h value or a plus h showing up in the equation, then you are going to report it as a horizontal translation to the left. Your k value represents a vertical translation or a vertical shift. And the k value, luckily, is very simple and straightforward. If you have a positive k value, that's going to represent a vertical translation or shift upwards. If you have a negative k value, that's going to represent a vertical translation or shift downwards.